Dimensional analysis is a way of using conversion factors instead of proportional reasoning to convert between different units. It requires a different setup than proportional analysis, and that's what we're going to look at here for 2. The molar mass of carbon dioxide is 44 grams per mole. How many moles are present in 32 grams of carbon dioxide? When you are writing dimensional analysis problems, you always want to start with the given number. 32 is the given number. 44 is the conversion factor. That's because it never changes. The molar mass of CO2 will always be 44. So you can use that in any problem where you have to use the molar mass of carbon dioxide. However, this problem is specifically saying 32 grams of carbon dioxide. That means it's the given number. That's the one that we're doing the math on, the one that is different from problem to problem. So we start with 32 grams of carbon dioxide, and then we need to set up the conversion factor so that it will cancel with the bottom. So that means also that what you're looking for is on top. So the question is saying how many moles. That means moles need to go on top. And on the bottom would be our 44 grams. The nice thing about dimensional analysis is that they cancel out. So just like if I had 2 over 2, the 2's would cancel out to give me 1 over 1, which is 1. It's the same thing with dimensional analysis, except for now we do it with the units, not the numbers. So we have grams of CO2, and on the bottom here, on the other side, we also have grams of CO2. You're multiplying these together in that what you're really doing is 32 grams of CO2 times 1 mole, because this is on the top here. This is on the top. Say it's over 1 if you really want to. 32 grams times 1 mole over 44 grams of CO2. When they're all together like that, you can see how the grams of CO2 cancels out with the grams of CO2. So really what we're doing is 32 times 1 divided by 44, and we're left with this moles of CO2. And if we solve for that, we get 0.73 moles of CO2.